Welcome back. Today we will be talking about angle and their measures, and this is the starting of the trigonometry unit that we will be doing this semester. So as you know, you have learned in geometry about the ray. Ray has the end point and it has the direction. So if I expand that understanding of a ray, and if the two rays are connected from the same vertex, it forms an angle, right? So that starting point is the initial side. So initial side is always on considered on the x-axis. From the initial side, if I move around or rotate on the vertex and form the angle, the another line segment or the another ray that will form the angle, that is called the terminal side. So this is a little bit new terminology, the initial side and the terminal side. You can consider it as the terminal is the end point and the initial side is the starting point. Even when you go to the airport, you enter the airport and your final target is that I need to reach to the terminal to board the plane. So the same thing. So the theta, I can represent the angle as theta or with any other uppercase letter or Greek letters to represent the angles. So let's talk about on the coordinate plane. So we are starting from the x-axis. We are rotating along the vertex and to form the angle. When the angle is formed, that ray is called the terminal side. Again, I represented the angle with theta. So if you consider this particular angle on the coordinate plane, again, my emphasis is that the initial side will always with respect to the x-axis. Now, with these, we can have two types of angle. We can have the positive angle. With the positive angle, we are generating positive angles by the rotation of the counterclockwise. On the coordinate plane, the counterclockwise always turns into a positive angle. For the negative angle, the rotation will be the other way around. So the negative angles will be generated if the rotation is clockwise. So unless and until it is specified, we always consider that the rotation is counterclockwise. That implies that the angles are positive. If they specifically mention the clockwise, that implies that the angles are negative angles. Now to represent the angles, you have done in geometry how to represent the angles. So labeling of the angles can be, I can use the Greek alphabets, alpha, beta, gamma, or theta, or the uppercase English letters A, B, C, and so on. So these are the ways you can represent or you can label the angles, but understand the initial side and the terminal side of the angles and the positive and the negative angles. Now with that, there is something called co-terminal angles. We just learned what are the terminal sides, right? So when we are talking about the co implies to share. So when the two angles, they share the same terminal side, those angles are called co-terminal angles. Let's understand. So we have a coordinate plane, and just to let you know, this video is comparatively quite long. The reason is there are so many concepts that we have to review from geometry and starting in this course. So again, we are starting from the initial side, that is the x-axis, and we are forming the angle, and I label the angle as alpha. And we have a terminal side, that is nothing but the ray. If I go clockwise and reach the same terminal, we are forming another angle, and let's label that angle as beta. So the two angles, they are sharing the same terminal side. So these two angles are called co-terminal angles. So the understanding is when the two angles, in this case alpha and beta, they have the same initial terminal sides, these angles are called co-terminal angle. So the basic idea is reaching the same terminal. No matter from where you are starting, either you are going the positive way or the negative way, but our destination is the same terminal. So you can write it down for your reference, reaching the same terminal. So coterminal angles, they are quite important. So after this, we can always say always the x-axis, always x-axis is the initial side. Okay, let's take another coordinate plane. So we have an angle right here. So this is my terminal. And to reach that terminal, again, if I start from the x-axis, the long way, that is a positive angle because counterclockwise. If I'm going from the clockwise, that becomes the negative angle. So positive angle and negative angle. Positive angle is formed counterclockwise, negative angle is formed clockwise. Now building upon this concept, let's talk about angle measurement. So few key things again to consider, because these are the basics. If the basics are pretty clear, then the things will be easier. So always remember the rotation from the initial side to the terminal. Again, initial is the starting, terminal is the end. Then we call these angles, we label these angles, or we consider these angles in terms of degrees. And a complete revolution about the vertex from where we are creating the angle, is of 360 degrees. And as I said earlier, unless and until it is specified, we consider it the rotation as counterclockwise. Now, if we have a ray and we can have a rotation, so this rotation, that is a theta, this theta will be equal to 360 degree. Right? So because with this, we can understand the different quadrants as well. So when we are talking about the measurement of the angle, we are saying the whole entire circle or the coordinate plane is of 360 degrees. So if let's form the coordinate plane again, and let's go back to the basic understanding of the coordinates. So you should have a very clear understanding which is quadrant 1, 2, 3, and 4. We have the coordinate plane, we have a 90-degree upright, then we have 180 degree on the left and 270 degrees, 0 degree, and if I finish the whole entire circle, it will be 360 degree. Now, which is quadrant 1? We always start with the quadrant 1, then 2, 3, and 4. So the easy way to understand the positioning of the quadrant is consider that this is nothing but a magic C. It creates a C, 1, 2, 3, and 4. Now in the quadrant 1, the angle is between 0 degree to 90 degrees. In quadrant 2, it is between 90 degrees to 180 degrees. Quadrant 3, we have 180 degree to 270 degrees. And in quadrant 4, the angle is from 270 degree to 360 degree. So this is the basics of the quadrants that you should be very, very familiar of. Because we need this concept to understand something that is called a unit circle. But before that, a few important things. Traditionally, the degrees, the fractional part of the degrees, were represented in the form of minutes and seconds. So fractional part of degrees, they are represented something called minutes, that is represented by a notation called prime, and second is represented by two lines, two small lines, that is called double prime. So minute is nothing but 1/60th when we are talking in terms of a degree, 1 degree. And the double prime is, as the second represents, second is nothing but 3,600, right? So 1 over 3,600, or 1/60th times 1/60th. And again, we are talking in terms of a 1 degree. You might have seen in some calculators, they have the notation as D degree, M for first prime, and S for second prime. So if a question is written something like this, 74 degrees, 34 minutes, and 37 seconds, the proper notation will be something like this, that theta is equal to 74 with a degree sign, 34 with 1 prime, and 37 with second prime. So if you find something written like this, they are talking the fractional part of the degree. That means 1 prime is the minute, double prime is the second. Now, let's take a few examples. So in this one, they are asking for find the co-terminal angles. And when they are talking about the co-terminal angles, so let's find out the positive angle and the negative angle as well. So the given theta is 55 degrees. So because it is 55 degrees, if you imagine on the coordinate plane, it will lie in the first quadrant, because in the first quadrant, angle is between 0 degree to 90 degrees. So let's form the angle first. So the half of 90 will be 45, so a little bit higher than 45. Just a rough estimate. This is approximately the 55-degree angle. Now they want a coterminal angle. That means the angle that share the same terminal. So if you want, you can label it the x-axis as the initial I, and the another side of the angle as t, which is the terminal side. Now I need a positive angle and a negative angle. Remember, when we are talking about the positive angle, we are talking about the counterclockwise, and when we are talking about the negative angle, we are talking about the clockwise. So for positive, because we are going counterclockwise, let's add 360. So the angle that we can relate to is 415 degrees. So 415 degrees, that means it will finish the whole entire rotation, and then it will come back to the same terminal. For the negative angle, let's represent with the yellow, we will subtract 360, and that will give you a negative angle. So negative angle implies we are going clockwise. So 305 degrees. So if I go clockwise, I will reach the same terminal. Same terminal at 305 degrees. And it is logical because 305 plus 55 will be 360, and that completes the whole entire revolution, the whole entire circle. Now, you might remember something called complementary angles and supplementary angles. So when we are talking about the complementary and supplementary angles, complementary angles, as the name suggests, it complements each other. That means when the two positive angles, they sum up to 90 degrees. Those are called complementary angles. Now, the supplementary angles, on the other hand, again, the two positive angles, when the sum is 180 degrees. So let's take example then. Now theta is 23 degrees. What will be the complement of 23 degrees? That means we are talking about what should I add to 23 to get to 90? Or on the other hand, what is 90 minus 23? Which is nothing but 67 degrees. So 67 degree is the complementary angle of 23 degree. On the same note, the supplementary angle, that means I need to add up to 180 degree. So how much should I add to 23 degrees to get to 180? That is nothing but 157 degrees. So complementary angles and the supplementary angles. Now the most important part is something called radians. You might have learned about the radians, a brief understanding of radians in geometry. So in radians is more used in calculus. In calculus, we don't use degrees, we use radians. So in a simple way, theta, or the angle, is nothing but the whole entire circumference divided by the radius. That is nothing but 2 pi radians. So technically 2 pi radians is equal to 360 degrees. And that will lead to the conversion from radians to degrees and degrees to radians that you have done in geometry. The another thing that you have done in geometry is the arc length. Arc length again is nothing but what is the length, or what is the total measurement of the circle outside rim. That means the circumference. So arc length, we represented by S, is nothing but the circumference 2 pi r. And with that, we can say theta is nothing but S over r, because S is 2 pi r and theta is S divided by r. That's what we did. And theta is equal to S over r. That gives you the 2 pi radians. So these understanding is very, very important. I will not say it is a formula. It is just a basic understanding of what the radian is. So radian in terms of angle is 2 pi radians, and that is formed by dividing the circumference by radius. As I said, you will be learning something called the unit circle, and in the next few sessions, we will be learning about how to create a unit circle on our own. So the basic idea of the unit circle is this. Uh, on the coordinate plane, we represent everything by degrees, but if we have to represent in terms of the radian, so 90 degree is nothing but pi over 2 radian, 180 degree is pi radians, and 270 degree is 3 pi over 2 radians, and 360 degree is again the 2 pi. Again, it is when we are talking about the radians, we are not substituting the value of pi. Do not substitute and say 3.14. Let me substitute pi as 3.14. We leave as pi radians. 2 pi radians, pi over 2, 3 pi over 2, because we are talking about the radians. We are not substituting the values in. So let's talk about the complementary and supplementary angles again, but in terms of radians. So they are asking for find the complement of theta, and theta is pi over 12. Now, what is the meaning of complement? Complement implies that the angle should sum up to 90 degree. If you look on the units on the coordinate plane on the right hand side above, 90 degree is nothing but pi over 2. So I need to add up to pi over 2. If I subtract pi 12th from pi over 2, that means 90 minus pi over 12. We cannot subtract degree with the radians. I need to find the equivalent of a 90 degree in terms of radians, and that is pi over 2. So pi over 2 minus pi over 12 will give you 5 pi 12ths. So be very, very careful with regard to solving the fractions. Let's take another example. In this case, they are asking for find the coterminal angles for theta is equal to 17 pi 6. Now we can approach this in a two different ways, or in many ways. So can I rewrite the fraction 17 pi 6, because it is a improper fraction, right? So let's rewrite the improper fraction into an addition fraction. Can I say 12 pi over 6 plus 5 pi over 6? Because the denominators are same, I can add the numerators together. And what is 12 pi over 6? That is nothing but 2 pi plus 5 pi over 6. That means 2 pi covers the whole entire circle, right? So it completes the whole entire circle, and that is a 2 pi. And if I keep on extending it beyond the 2 pi to 5 pi 6, that is what the angle is. Let's reconstruct it. And that will be 5 pi over 6, and that will land in the second quadrant. So that is the terminal side we are looking for, and we need to find another angle that will share the same terminal side. That is 5 pi over 6. Okay. The other way to approach is, if I subtract 2 pi from 17 pi over 6, that will also give you 5 pi over 6, just using the simple fractional. Right. Now, as I talked earlier, let's talk about converting degrees into radians and radians into degrees. Okay. So in geometry, you have converted degrees into radians and radians into degrees, because sometimes we need to write the answer in terms of radians instead of degrees. So the process is very simple. So recall from geometry. So whenever we need to convert radians to degrees, we would like to introduce degrees and take away radians. And how to do that? We can multiply by 360 degrees and divide by 2 pi radians. So, or if you simplify it, it is nothing but multiply by 180 degrees and divide by pi. On the same note, if we have to convert degrees to radians, introduce radians and take away degrees. How? Multiply by 2 pi, divide by 360. And that is nothing but multiplying by pi, dividing by 180 degrees. Now, I really want you to try one question on your own. Convert to degrees. Give it a try. You can pause the video and try these two questions on your own. And after that, we will go application form for arc length. So our two problems are pi over sixth and 5 pi over third. Okay. After that, we will talk about in detail arc length. As we discussed earlier, arc length, when we are talking about the arc length, we are talking about the outside of the circle, right? Outside rim of the circle. So S is nothing but, the arc length is nothing but radius times theta. And theta is always written in radians. So if angle is given in degrees, first you need to convert it into radians. Never use degrees for theta. So when you have done arc length in geometry, they use degrees, and that's why they convert it into radians. In this case, we are just considering the angle in terms of radians. So let's take one example. So the radius is given as 27 inches, and the central angle is given as 160 degrees. Again, now this is degrees, right? So my first line of action would be to convert the degrees into radians. And they want to know what will be the length of the arc. So first thing first, let's convert degrees into radians. So for that, because we need to convert it into radians, we will introduce radians. So 160 degrees times pi divided by 180 degree. Now the pi, do not write the value of pi as 3.14. This pi is pi radians. And that will give you the angle as 8/9 pi radians as theta. We have theta, we have radius as 27. Let's multiply them together. So 27 times 8/9 pi. And that will give you 24 pi. At this point, you can leave the answer as 24 pi, or you can plug the value of pi and then write the units. So the units will be 75.39 inches. So that is the length of the arc, because we need the length of the arc. So at that point, we are ready to convert, to write or substitute the value of pi. Few important things. S is equal to r theta can be used to analyze the motion of a particle moving at a constant speed along a circular path, because S is nothing but the circumference, right? Circumference implies it is moving in the circular path. When a particle is nothing but any object, is moving along that circular path at a constant speed. That is the basic idea of r theta, circular path. Now, with the concept of arc length, there are two things that we need to talk about. We are talking about the constant speed, right? Let's talk about linear speed and angular speed. So the linear speed is nothing but it measures how fast the particle moves. And it is denoted by or represented by the letter v. Now, what is v? V is nothing but arc length divided by t, and t is nothing but time. So when you divide arc length by time, that becomes the linear speed. On the other hand, when we are talking about the angular speed, we are saying it measures how fast the angle changes. And angular speed is represented by the Greek letter, which is called omega, and it is written as lowercase w, represented by Greek letter omega or lowercase w. Now, what is w? Because we are talking about the angle, so it is theta divided by time. And if we combine these two, so because S is nothing but r theta, right? And if I divide both sides by t, what we will get? S over t is v and theta over t is w. So we can have another identity. With this, we can say linear speed is nothing but radius times angular speed. And it's quite amazing, right? With one thing, we can derive the another. So, in other way, linear speed is radius times the angular speed. So these are few things that you need to keep in mind with regards to linear speed and angular speed. Let's take some application problems. So write down the problem. The second hand of a clock is 8 centimeter long, that is given. And the question wants you to find out the linear speed of the tip of this second hand. So if you understand the analog clock, it has an hour hand, minute hand, and the second hand. So when the second hand finishes the whole entire circle, that represents 1 minute, right? So they are talking about the linear speed. What is the linear speed? We just talked about linear speed is nothing but S over T. And what is S? S is nothing but 2 pi r. What is r? R is given as 8. So 2 pi times 8, and S will be 16 pi centimeter. That is the length, right? The outside length, the circumference of the clock. And T is 1 minute or 60 seconds. So it needs 60 seconds, or the time that is needed to travel the whole entire distance. That means to cover the 1 minute. But they want the answer in seconds. So we have all the ingredients ready. We have S, we have T. So let's write the linear speed. So the linear speed is 16 pi, which is in centimeter, divided by 60 seconds. And if you plug it in your calculator, you should get 0.8377 centimeters per second, because speed is represented with respect to time. What is speed? Speed is distance over time, right? So circumference is the whole entire distance, and with respect to time, time in this case is 60 seconds. Let's take one more example. Now this question says, the circular blade on a saw rotates at 2,400 revolutions per minute. Now there are two parts of this question. The first part asks for angular speed of the blade in radians per second. And the second part is it is given that the blade's diameter is 8 inches, and they want you to calculate what is the linear speed of a blade tip. So for the angular speed, I know is nothing but theta divided by t. And what is theta? Theta is 2 pi r. 2 pi is nothing but each revolution. And how many revolutions are happening? 2,400. So 2 pi times 2,400, that will be equal to theta. Because 2 pi represents one revolution. So in total, we have 4,800 pi radians as theta. And t, they want in seconds. That means the time is nothing but 60 seconds, because 4,800 pi radians is in minute per minute. Because if you read the question, it says 2,400 revolutions per minute. I need to convert minute into seconds. So t is equal to 60 seconds. So let's put it in our angular speed. So 4,800 pi divided by 60 seconds, and you can simplify it. It will be 80 pi radians per second, because the question is asking for per second. If it asks for per minute, you can just leave the answer as 4,800 pi radians per minute. Now, for the second part, the diameter is given as 8 inches. So when diameter is 8, the radius is 4 inches. And they are talking about the linear speed. Linear speed is nothing but s over t. That means r theta over t. R is given as 4, and I know theta from question number A, which is 4,800 pi. So let's multiply them together and divide by t. So S will be 4 times 4,800 pi. That is 19,200 pi inch. Remember, S is the circumference, so it is represented in units. And T will be in seconds. So our linear speed will be 19,200 inches divided by 60 seconds. Now, in this particular question, they have not asked us whether it should be in seconds or minutes. So if you want, you can leave the answer in minutes as well. Inches per 1 minute, right? Now, the last part of this unit, 6.1, is called area of a sector. You have done area of sector again at the introduction part in geometry. When we are talking about the area of a sector, and understand with respect to you have a cake, a round cake, and you are taking a slice of it, or you have a pizza and you are taking one slice of uh, that particular pizza. What is the area of that slice? That is called the area of the sector. That one portion is called the sector. So we have the angle, and the two sides are R and R. That means that represents the radius because we are cutting it from the center. So what will be the area of the shaded region? That is the area of a sector. So area of the sector, when we are talking in terms of the radians, is 1/2 r squared times theta. Theta is nothing but the central angle, and remember, it is measured in radians. We are not talking about degree at all. Let's take one quick simple question. Let's have a windshield wiper that is of 70 feet long, and it is forming an angle while wiping. So the other side will also be 70 feet because it is just swiping here and there. So the angle that is being formed is 120 degrees. Now the angle is 120 degrees, but we want theta in radians. So the shaded area is what we need to find the area of this shaded part. And I know from the formula that the area of the sector is 1/2 r squared times theta. R in this case is nothing but 70 feet. But I cannot take theta as 120 degrees. I need to convert 120 degrees in terms of radians. So let's convert it. So it will be 120 degrees times pi over 180 degrees, and that will give you theta as 2/3 pi. So we have theta as 2/3 pi, we have the radius as 70. Let's put everything together. So area will be 1/2 times 70 squared times 2 pi thirds. And when I plug it in the calculator, or you simplify it, you should get approximately 5,131 feet squared, or you can say 5,131 square feet. Because remember, area is always represented in square units. So this is the whole entire introduction of the angle and their measurement. Understand it really well, pause whenever you want to, and reflect back to it, and because this will form the basis of trig. I will see you in the next video. Bye-bye.